we don't use the word revolutionary lightly, right? So we're going to talk about our jetted denture solution. For those who were here last year, you might have seen me here speaking about this as well. So that was our technology preview. But this year we're really, really excited because we have a lot more things to talk about and to make it available to you. So what are we actually talking about? And this cable, I must be careful. This is a true monolithic denture system, right? So what we are bringing to the world is not a multicolor printing technology or a multicolor denture. It is multi-material. There is not a denture in the world that I know that works, that has the same material for the base and the teeth. It's kind of the lecture that we gave last year. And this is really the ground of our technology. We started this development a little bit more than 5 years ago with our team in Wilsonville in Oregon. They have the MultiJet technology that they have been developing for many years, more than 25 years of experience with MultiJet printing. From the start, from the beginning, we really focused on material development. Coming from NextDent, Vertex Dental, for those who were in the previous session, I gave a little bit the history. We know our materials, but we also know and experienced what doesn't work. So we have our 3rd generation of NextDent base in the market right now, which is an awesome material, really strong. But before that, we had 2 versions of a base material in the market that unfortunately, you know, they were innovative, they were new, but they didn't really work. They worked great, but if you drop them, they would scatter in 1 million pieces, for example. They didn't have any impact resistant, they were brittle. And that's the nature of development and innovation. You develop something, you bring it to market, and you learn that it might have some defects or need some improvements. And that's why we have our 3rd generation of NextDent base in the market today. And that is why we focused our development of the jetted dentures on material development first. We want to have a multi-material denture which has the perfect properties for the base, strength, impact resistant, and teeth, hardness, wear resistant. Of course, we're not just bringing this multi-material denture or this multi-material denture to the market. It is also a complete production method that will really change the way that labs work. We all know that it's very difficult to find skilled labor. I just recently heard from somebody that in the US before COVID, there were like 65, I think, CDT training centers or schools that you can go to, and currently there's reduced to 12 or something nationwide. Numbers slipped a little bit, but it was impressive to hear that you know, it makes, of course, we cannot find the people that are willing to do this in the future probably, but also the chances and the educational systems are reducing a lot. So we try to kind of give an answer to that by making a workflow that is easy to learn. Everybody can learn, and that really reduces the labor time. Let's use technology to our advantage. We have some pictures. I'm not going to show a lot of pictures about dentures. I think everybody knows what a denture looks like. We have samples on the table there that you can not only see but also feel. And tomorrow and the day after, we have a bunch of samples at our booth. So I invite you all to come and check out our booth, where you can really touch them, feel them, and experience the strength. But once again, by using 2 materials that are optimized for base and for teeth, we really enable to create a long-lasting, durable denture for your patients. Question?
Are they the same materials as for the DLP printers?
They are not completely the same materials. Jetting technology requires a few changes in the chemistry or has some limitations still. But they are developed towards the same mechanical properties. And of course, biocompatibility, right? There is a slide on that, so they are very similar, but you will see the mechanical properties in comparison. So, without further ado, here is the NextDent 300. So, it is alive and kicking. NextDent 300 we are announcing today at the show, and please visit our booth in the next day. So it is actually at the booth. You can see it firsthand. A few things that you might have seen in the video is the shade, the tooth shade that can change. We'll talk about that a little bit later. This is an important feature. You have seen the machine with the intuitive user display, so it's super easy to use. You have seen 3D Sprint in the video, which is an important part of everything that we do. Every technology that we develop, 3D Sprint is at the core of it. So we'll talk about all these features now for the next almost hour. And like I said, later, please touch the parts. Very, very strong part of the video, I believe, is when you see the parts actually grow on the platform and you can see the multi-material at one time. We have some examples there actually where we stop the print at different levels, and you can really see the combination between the support material, the build, and the 3 build materials for the base and the 2 teeth material. But it's more than just a printer. So it's really important technology development that we did, but it's not just a printer that we are announcing today. We can just give you a printer and say, bye-bye, good luck, you will not be printing good dentures. It is a complete process, it's a complete workflow that we developed. And the printer, the software, and the materials is really our specialty. That's where we excel, of course, and that's what we bring to market. But we connected it with all the parts and pieces that you need so that we can give you the full solution. That if you buy into this technology, if you buy into this system, you will be printing dentures the day after the installation or the day of installation. It all starts, of course, with the patient. The patient is sitting in the chair and will get an impression. Could be a digital impression immediately, an intraoral scan of the edentulous jaw, or copy denture feature, or you take an impression and you digitize it. Goes into a dental CAD software. We love them all. We love 3Shape, we love Exocut, but even the newer softwares that are coming to market, AI-generated, web-based platforms, they all will design a denture up to your preference, and they will give us the files that we need to print. So it's all it's a very open system. We are not close to one file input or whatsoever. There are some rules of the files that we need, but we are also including that in the design software so that you can start your design knowing or selecting that you will be using the NextDent 300 workflow, and we will get the files, automate everything. Once the design is finished, we use our 3D Sprint software to prepare a platform. Now, on one platform, there could be around 15, 17 dentures in one platform. So if you would have to load them all in, position them, support them, it's quite a lot of work. And of course, that's work or labor time that we want to reduce to the absolute minimum. And also there, we have succeeded in doing that by just automating the whole denture workflow, importing the file, and most of it will be done automatically. There is no need to generate supports, and even the placement on the platform is automated. We have the production on the NextDent 300 machine, and afterwards there's a post-processing workflow that we'll dive into a little bit deeper because we're going to share all the details about that. NextDent 300 is based on our MJP2500 technology. Now, that might not mean something to most of you, but just know that this is our most reliable and successful MJP product that we have had in the history, let's say. Is in use by a lot of dental labs already to print models, but it could do only one material. So now we added some more channels. So we have 4 channels in total, 2 printing heads with 2 channels each. And with those 4 channels, we always need one for the support material, which is a wax material, just very easy wax, melt away wax material. And then we have 3 channels left. One is for the base, the pink material, optimized, like I said, with the mechanical properties for a denture base. And then 2 teeth materials, one very white, one what we call yellow, but a darker shade. And those 2 we can digitally blend, we can mix them, and with this mixture we create 2 shades. 2 shades that we also base on the Vita Shade Guide, of course. At launch we will have 5 shades available, A1, A2, A3, and B1, and a bleach color. And we have currently one base shade available. There will be more base shades added, but unfortunately, or the reality is that you kind of select your base shades for the printer that's loaded in the material. You can change it later, but changing materials on an MJP system is not that, let's say, easy. It takes some time and you're wasting some material. So it's better to, usually you have a base shade that you use the most, that is loaded into the system, and the two shades can be matched digitally. The user interface is a new thing, so you can move it upwards, you can put it flat, but also make it stand up. So it gives you a very good overview. If you're working in the lab, you can see on the screen, what's the status of the machine. If there is something wrong, you will see it, but also when it's printing, there is an image of the job there. It's a very nice user interface. Now, of course, if you are a production center, and we hope you all buy a lot of these machines, it might be also a good idea to add the optional stack light here, which is a more industrial look. It's a magnetic, it's optional, you just plug it in, you put it on there, and you can always have an overview. So more an industrial solution, you can see the status of your printer. Green, everything good, it's printing. Orange, this job is done, it's waiting on you. Red, something wrong. Doesn't happen, never red. Yeah.
So you see there like 1, 2, 3, 6, 8 cartridges. So 2, the big ones, are for support.
Yeah.
And 2 for base. And 2 for 1-2 material, and 2 for the other 2 material, right?
I didn't pay him, but that's a perfect bridge into my next point. Indeed, so you see 4 channels, but you see 8 slots in the material cartridge. So the 2 white ones are the support material, and then we have the 3 materials that I just talked about: base, teeth white, and teeth yellow. But every time a secondary bottle is what we call the redundancy bottle. So it actually means that this is a production system. So the printer will work all day, every day. You just stop when it's finished, take one platform out, put in the new platform, start a new job. It will automatically detect if the material bottle is empty, and then just switch to the second bottle. You'll have a warning on your screen that there is an empty bottle, or you can just go in and see what's the status of all the bottles, the material levels. And even during printing, you can just open the material drawer and replace the empty bottle with a new bottle, close it again. The printer doesn't have to stop for that. You don't have to interrupt the production. It just keeps on printing while you're replacing those materials. So it is 4 channels, 4 materials: support, base, teeth white, and teeth yellow. And then every time a second bottle of the same material. 1 kilogram.
1 kilo per bottle?
Every bottle is 1 kilogram of material, and then the support material is 1.4.
How many dentures can be done with one bottle?
Don't have that top of my head, but we have some calculations on TCO and stuff like that. The thing is, one denture is on average about 23 or 28 grams of material, and then you have some material waste, of course. You have the support material. What we can say is that in our calculations, based upon all the dentures that we have been testing, average weight and material consumption, the fully burdened cost of a denture, one denture, which means the investment of the system divided by 5 years, let's say, and material cost is just below $25. So that's one of the numbers that we are sharing today. So key dental indications. Another important thing about to know about the system is actually we are 3D Systems. We work for all these different industries. This product, the NextDent 300 with the 4-channel printer, is only one application today. So we really developed this as 3D Systems for the dental market, for the dentures market. It is really developed for digital dentures. What we get from MJP technology is the highest accuracy available. So all other 3D printing technologies are good. We have been printing dentures and crowns and bridges on DLP systems, and they definitely work. They succeed. They are very accurate. But the comparison with this system is night and day. The accuracy that you get from this system is really high. Has to do, of course, with the printing technology, that we are not curing and pulling, and there's no delamination, there's no sagging of the material. Also has to do with the support material. The support material is a wax material that will melt away, and it's not attached to your part. Well, while with the DLP, you are using the build material for support generation, which is connected. You have to break off or cut away, leaves little markers all over the part that you have to remove. Also, down-facing and up-facing surfaces are a thing of the past. So you have a full 360 accuracy of the denture. So it's really an accurate technology, which helps a lot with these dentures. Yes?
When you want to do a material swap,
yeah.
let's say changing the base material to a darker color, for example.
Yeah.
Can you do it just by changing the bottles, or do you have to make a...
Yeah, you have to what we call purging. So there, the material that is already in the umbilical cords or in the system, you just flush out. Yeah, sure.
Similar question, but if you have A1 dentures and A2 dentures,
yeah,
you can't print them at the same time.
You can, yeah.
Or you can.
Yeah, so that's why we have the white material and the yellow material. We can mix them digitally together, and we have presets for A1, A2, A3, B1, and bleach.
So I can have two A1 and A2 printing at the same time.
Yeah, you could even have an individual shade for each tooth.
That's cool. And how long is a print take?
We announced the full platform is about 15 dentures, will be between 9 and 10 hours, depending on a little bit on the size. So 9 to 10 hours print job.
For the whole platform?
Of course, yeah, for the full platform.
And if it's not full, if you do on one denture, you know what that time is?
4 hours. You tested it. Now we have 3 lanes. Not sure if that actually comes in the presentation later. So the platform is made of 3 lanes, which every time the printing head covers one lane and goes to the next lane. You could optimize your production in a way that you say, okay, I'm using 5 dentures in one lane, or 10 dentures over 2 lanes, or 15 dentures on average on 3 lanes. And with this, you can plan your day a little bit. If you're planning on, you start your day at 8 and you want to have, let's say, 10 dentures by 4 o'clock. You just do 2 lanes during the day, and then you prepare a full job afterwards for the night, for example. So you can optimize. If you have a rush case that you say, oh, shoot, I forgot the patient is coming tonight and I didn't print by parts, just put the 2 dentures on the one lane, and then it goes pretty fast. An important part, we'll talk about the post-processing, which is a very important part of the whole solution. But the wax is an important part of that, so that it really means no support scarring, layer delamination or deformations. And it's really an easy, kind of almost hands-off, hands-free post-processing system, which doesn't require any alcohol-based solvents, and we don't have the need for post-curing. So the parts come out of the printer fully cured. Talked about that earlier, so you can see here the 5 shades that we will have at launch: A1, A2, A3, B1, and bleach shade. We have the base. The first base that we will have at launch is called LT, and that's because it's based upon the most popular denture-based shade, which is, in our opinion at least, Dentsply Lucitone Original Pink. But we will be adding at least 3 shades to that very quickly after launch. Probably based on our Vertex shades, 5, 7, and 10, similar to our NextDent base material, but of course highly impacted by the feedback that we are getting from the first users, what kind of shade that we have to make, because we do have some freedom in that. We started out smart with the biocom testing, so we have some playground there. Yeah?
Does the teeth material have filler content?
There is no filler content besides pigment in these materials, and that's a limitation. That's part of the jetting technology. So these printing heads, of course, are little jets. Viscosity and all that is optimized for jetting. And again, we didn't pay him, but it's a very good bridge to the next point, talking about materials. When we talk about mainly the base material, that's the most important. The base material is really what we need to focus on for dentures, because of course We want dentures to last and not break when we're using, not break when they fall in the sink, or when you eat a soft sandwich. Yeah? That's usually when they break with most patients, when they were eating a soft sandwich. To compare the materials with known materials in the market, the most important requirement is actually the total fracture work. That is actually your impact resistance. It's the amount of energy that the material can absorb before it breaks, before it cracks. If you look at the graphics that we have on the screen, and you might not be able to read all that, I will go through them all, but it is very important to know that these values from other systems don't come from marketing material, they don't come from hearsay, they don't come from websites. We actually ordered these materials from all these companies and material suppliers using the ISO requirements for test specimen. And we tested them all in our labs the same way, same procedure, with the same equipment, same circumstances as we do all our own testing. So apples to apples, direct comparison. On the left side, the orange box, that's our new material. That's NextDent Jet base. We want to compare it to our NextDent base, which is our third generation of base material that we have. Just for reference, we included NextDent Denture 3D Plus, which was our second version of the base material, where you can already see a big difference. Then we go into the market. We have another jetting competitor that we have the parts printed for and tested is here. What we call a premium DLP resin. So there is a few resins in the market for denture bases, but there is only, I think, one or the most known resin in the market currently for printing DLP dentures. We tested. And then we have a conventional material on the right side, the absolute right, but it's not just a conventional denture-based material. This is a high impact, known as a high impact denture-based material. This is from Vertex, the Implacryl, so it's our own resin, our own material. And then you see here the slide. This is the total fracture work expressed in joule per square meter. NextDent Jet base, we are at 1,225 joule per square meter. So that is a strong material. Just a second. Compared to our NextDent material, which is about 1,000, and then we see a drop, NextDent Denture 3D Plus, around 300. I was very honest in the beginning. We made a third denture-based material for the DLP system on the NextDent because the previous one didn't work. They broke, sorry to say, but they did. And you can clearly see that here. You can clearly see that at the numbers. And then compared to a high impact material, we are actually slightly above that. We also have the maximum stress intensity factor. That's actually when there is a crack. You know, how much can it withstand before it completely breaks. You can also see these numbers here. This is megapascal per half a meter. So NextDent Jet base again, our base, Denture 3D Plus, jetting, premium DLP, and high impact. So, question. Sorry, you were first.
Yeah. Can't you use then also the NextDent Jet base for the DLP system?
That material on the DLP system?
Yeah, because it's the same curing process.
It is a similar curing process, but, well, we can test it. Yeah. Do you know?
I think it's a different wavelength.
Wavelength, yeah. Okay. Sorry, a question?
How does it compare to regular PMMA?
Regular PMMA, so we have the high impact. Sorry, regular, like milled, you mean? Yeah. Milled, we didn't include that, no. We know that milled dentures are very strong. I know that's a given. So I don't have that number, so we didn't include that. We did some testing, but it was, anyway. Let's talk about the production process. So I think we have also the dentures, of course, here and at the booth. And again, you can touch them, you can feel them. It's really give you a good impression of how good they are. Talking about now how easy it is to produce them. Like I said, we have 3D Sprint, very easy job preparation. And then you can see again, like a drawing of the technology of the printer. The platform starts here leveled and then is slowly going down. print head moves over the platform where we have two jetting heads with two channels each. So little droplets are being depositioned. A planarizer, making sure that we are always on a flat top. And then a UV light on the carriage. So immediately after depositioning the material, it is cured. Little video, little bit, I have to start it. This is our 3D Sprint software. You can see the platform, NextDent 300 there. Just select the files that make the denture. In this case, the teeth are split in three parts. So the tooth arch is in 3 parts. You select the tooth material, the tooth shade, automatically finds what is the monoblock, what is the teeth, and what is the base file, and set on the platform. So that's the labor part. You import the files, select the shade, and it places them. We have an engraving option, which is pretty cool actually. Just put in the name of the patient there, and it's not embossed or embedded. It's actually flush with the surface, and we use our tooth material to just engrave the name into the denture, which is a very nice referencing tool as well. So it can stay there. You can put it anywhere you want on the denture, and even for nursing homes or whatever, the patient have a reference, their name or a reference on the denture. So one by one, you import them, engrave them, just put in the name, put it on the position or the place of the denture where you want the name to be visible. Once again, this is not sticking out or inside the material, or you cannot feel it. It's really flush with the software and just a white marking reference. Then there is a step to prepare the files for printing. So that's what's happening now. Depending on how many cases that you have, this could take a few minutes, actually up to maybe even 10-15 minutes if you have a full platform, but this is non-labor. You can minimize the software, let the software calculate, do something else, use your computer for any other software that you have. It's using only CPU. So even making the design in 3Shape for another denture is actually possible, as long as you of course have a good gaming computer or a CAD computer. On the right side in the part list, you can see a little bit the status per parts. Green check mark means everything is done. The orange clock means it's currently calculating or doing the calculations for that denture or for that part of the denture. And then red means there's something wrong, but at the end, everything is repositioned, everything is optimized for production. And Z height, putting them in the right lanes. If you would have imported multiple files, would be all placed on the platform. And now it says print to file. And normally it says add to queue if there is a printer in the network, and you just send your job to the printer. So labor time is just selecting the parts, making sure that the right tooth shade is assigned, making sure that the software has automatically identified them correctly, monoblock, base, and teeth files, and then labeling if you want. It's optional, you don't have to. Put in the reference there, and then let the computer calculate and send the job to the printer.
When we're doing your output files, you're just outputting STL files?
Yeah.
Just the 3 monoblock teeth base?
Monoblock, teeth, and base. So with 3Shape, there will be a DME file. So it's 3Shape, you select your design output. Execute, there is also a database for NextDent available that will, in Execute, you can use your file. And for any other software, in the installation guide, in the training, there are the specifications. So you have the output needs to be with a 0 gap. So the teeth and the base file have 0 gap in between. Minimum thickness is 2.5 millimeters, just like I think any other digital denture system. And we can receive STL files, what is it, PLY, OBJ, 3MF, we can all receive and load that.
So if I send you guys files to try out a denture, I can just say,
absolutely. You can do that. As long as we have a monoblock, we are even if there is a gap, and that we really want to ask everybody to design it without a gap. But even if there is a gap in the design output, as long as we have the monoblock, we can work with that.
The color is dedicated in your software, right? So you select, let's let's say A2 or whatever in your software,
Yep.
can you also take over metadata from Exocad or 3Shape or something like that?
Yeah, so with the integration of Exocad and 3Shape, there will be the list of the available materials in 3Shape as well. So you select it in 3Shape. We receive the metadata, so the XML. We currently are not yet making the API or something to really import that. So you just have to select it in our software. But yeah, that is stuff that we will automate even further later on. But at launch, it's just in 3D Sprint, one checkbox. There are 5 options. So
Can you get a color gradient on the teeth? Or is it just like a...
Well, the printer can do it.
Yeah.
The technology can do it. This is a matter of libraries and software. So we currently start with, let's say, monochromatic teeth. Like I said, if you have an export of an individual STL of each tooth, you can actually individually select the shades. Now, in the future, of course, there is a lot of, it has already started, a lot of integration work with other companies, with tooth library manufacturers, for example, to make special libraries that are made out of different components so that we can actually build them up with a natural, like a more opaque core and then lighter and translucent.
Right now, it's just...
Well, like I said, the printer can do it if we put in the files. It's just that currently that is not available in none of the CAD softwares, and also the shade optimization work. So just to get it right, still needs to be done. So the idea is indeed that if in the near future, that if you select an A2, and you take an A2 from the Vita stock, let's say, teeth, and you compare them, that you can see not only the same shade, but also the same natural, translucency and build up with the animals, etc. All right. Once it's printed, you're not done. You're almost done, but not completely. And this is a very important part that we want to talk about as well, is the post-processing. Everybody, or most of you, have experience with DLP systems that you have to wash them first in IPA or ethanol, with the smell and headaches afterwards, and then you have to post-cure them. Well, none of that with the MJP or with the NextDent 300 process. On the left side, you can see the result of one printed platform, so about 15 dentures there. They are completely supported and wrapped around in wax, and this is also an important part about the process. It's not just supported by the wax, but the whole denture is covered in wax. And this actually enables us to fully cure the part during printing. We all know the oxygen inhibition layer while you UV cure acrylics. So during print process, we enable actually the fully curing of the material so that you don't have to post-cure them. And that's because of that wax, looking for the word now, encapsulation.
The inhibition layer is basically...
is gone. We fully cure them. Because they're completely encapsulated in this wax. So the parts are removed from the platform. You do that we do that now in a freezer. You have 2 options: or you heat the plate, or you freeze the plate. It's a metal plate. It shrinks or it expands. The wax is removed from the platform, so the attachment is kind of broken. You have all the parts separately. Takes about 10 minutes in our freezer. You put it in an oven. It's just a forced hot air oven, 70 degrees centigrade, for 2 hours. Well, this could be a little bit less, but 2 hours is really a good number for a full batch, that all the bulk wax is melted. So just starts melting, the wax starts melting away. 2 hours later, you can take out the dentures. There is no wax anymore. They're just a little bit wet. You need to clean them. You put them in a ultrasonic bed, a heated ultrasonic bed, about 65 degrees centigrade again, with mineral oil. And then for about 30 minutes, you rinse them or you clean them with some soap. And then we have a final step, what we call the wet bead blasting. This is a necessary step to get the final surface features, the surface smoothness, and then you can polish the denture. You can see here the process in the oven. So after about 30 minutes, we opened the door, took this picture. It's just to show you that, you can see the wax melt away. We pick it up, or it's captured in this little basket or tray below. And then after 2 hours, these dentures are completely clean. There's no more wax, no more bulk wax on the surface. Take it into the ultrasonic bed. There is the mineral oil that we use. About 15-20 minutes, letting them clean in mineral oil, and then one cleaning step to remove the mineral oil. And then your dentures are ready. No post-curing, no IPA or alcohol-based solvents required. Dentures, no gloves, no nitrile gloves necessary. You can just take it out with your hands. There's no dangerous goods, no dangerous materials. But very important step, the last step of the post-processing is what we call wet bead blasting. You might all know the sandblasters, you have that in labs. This is a combination between water and media, blasting media, 25 micrometers in size, with 2 bar pressure and an 8 millimeter nozzle. We really just blast the whole surface. Just make sure that you smoothly go over the whole surface, inside and outside. Why is that? After printing, the surface is still a little bit, we call it the frost look, like they're a little bit frozen. There's a little bit of a reaction between the wax support and the build material that gives it a little bit of a rougher surface. Now, the intaglio surface of a denture you don't want to touch, so we just blast that off, and that is the final surface. If you take a look at the dentures later, you can see that that surface is really, really smooth. What you need, of course, because it goes into the mouth. And then you also have externally the perfect, let's say, surface start to do a very, very quick polish. Looking at the polishing, it's very standard denture work, but it's very quick pumice, making a good wet mixture. We use muslin rag wheels for that, for pumicing, but also for high gloss, same rag wheel. In this case, we use this Renford Universal polishing paste. It's just a few minutes, doesn't take a long time, and you get really high gloss dentures. Question?
You got staining this material?
Sorry?
Staining and glazing?
Yes, absolutely. Actually, we have a Dracula denture over there. So Lars, our application engineer that you see there, usually has the creative ideas, and there is indeed one that is, Dracula teeth and has some staining on it. And I didn't pay you either, right? So also, again, a very good transition into the biggest question that we always get. Actually surprised that nobody raised their hand and said, but can these dentures be repaired? Yes, they can be repaired. Of course, you're gonna just print a new one. That makes all the sense in the world. But of course, a patient shows up at the doorstep and says, I have two pieces. I ate a soft sandwich. But this morning I was eating a soft sandwich and my denture broke. At least you're able to help them. In this case, we use self-curing resin. This is from Vertex, from our own company. There are different, of course, brands that you use. Just self-curing, cold curing acrylic. What is important, and I just mentioned that also to show that we tested that and we validated that. Just make sure that the surface is roughened a little bit and apply 1 or 2 layers of the monomer, so the liquid, the pure liquid, on the edge, maybe 1, 2, and let it dry. Follow the IFU. I know it's difficult. I know we don't like to read instructions and follow them, but follow the IFU and you will succeed. Make sure that you apply it correctly, that you let it dry, then you prepare your dough, apply it, and you can just polish it off, and you have a strong repair. Lars, you can see him there, is a big guy, strong guy, and he has a video of him trying to break it again, and he didn't succeed. So that's our calibrated test right there. No, it works perfectly. You can repair printed dentures. It's a big question that everybody raises. There are, of course, materials, UV curable materials, that are a little bit more tricky because of the mechanical properties. Also, if it's really flexible, it becomes more tricky. This material is really in line, as you have seen, with the standard high impact traditional materials, and also can be repaired just like you did before. Quick overview of the full solution. We are not just announcing a printer, it's a full workflow, it's a full process, which you can see here on the screen, a quick overview. 3D Sprint software, 3D systems. The printer, 3D systems, gives you a full platform of printed dentures with 3D systems materials. Then you have a hot plate or a refrigerator to remove the parts. That is third party. We help you, or we can guide you which one that you need, but we are not making that, we're not selling that. Hot air oven, also that. There are a lot of good ovens available in the market at perfect prices. We can give you the specifications, we can give you even brands. We help you, we are not making it. Ultrasonic would be really stupid to sell you an ultrasonic bath, right? I think everybody has that or knows where to get that. And then we have specifications on the bead blaster. That is a little bit of a special device that is not very current available in most labs, but it's just a necessary part. And then of course the polishing lathe. If you look at the complete workflow, we kind of measured the times needed, both in labor and in total time. If you look at the preparation of the files, a full platform, labor time, it's closer to 5 minutes now than it is to 10 minutes. And actually, the software does everything for you. Printing, setting up the printer takes about 5 minutes, a few minutes to put in the platform, hit start, it starts. 3 to 9 it says here, it's 4 to 10, let's say, hours, depending on 1 lane, 2 lane, or 3 lanes. So a full platform in less than 10 hours. Removing the platform takes about 1 minute, and then you put it in the freezer, so about 10 minutes of non-labor time. Bulk wax removable, 2 minutes, it's depending on the distance between your freezer and your oven, right? So you just have to take out the parts and put them in the oven. And then 2 hours in the oven. Fine wax removal, again, just touch time of 2 minutes, 20 minutes in the ultrasonic bath. And then here, the last 2 steps, here we go per part. So wet bead blasting currently, just with the team that is our dental technicians, but also just engineers that we have in the office, we let them bead blast. Takes about 3 to 4 minutes maximum, even for a non-experienced person, just to clean them up completely. 3 to 4 minutes per part. And the same for polishing, we all know that. You can do that in 3 to 5 minutes. Overview of all the equipment. As I said, I was explaining, this is what we actually make and sell. And this is what we developed in the whole process, that we help together with our partners get the whole system into your laboratory, so we can help you assist with what to buy or what to get. If you have already an oven, just look at the, can it keep 70 degrees at the plus minus 5 degree accuracy? Is it hot air? That is important, and unforced air. One thing that we didn't talk about yet, some of you might recognize our NextDent roller mixer. So that is a device that we had introduced in 2018 together with the NextDent 5100, because the materials need to be mixed, heavily filled materials, they need to be mixed. We have it here as well because the pigment of these bottles, the material, if you leave it in storage for a long time, they also settle a little bit. So before you use your bottle, just put it on the roller mixer for an hour or 2, or overnight, doesn't matter. You cannot overmix it. Then you can put it in the printer, and it stays there. You start using it. Now, in case, but it will never happen, but in case you are not using your printer for 2 weeks, will never happen, of course, then also before you start your next job, take out the bottle, put it on the roller mixer, just let it mix in again, and then you can continue to print. It's just a precaution, but yeah, who is not going to print dentures for 2 weeks? That doesn't exist, right? So step into the future, print full dentures in one process, multi-material, very important, clean process, high accuracy. Yeah, and you can do a nice production per day. So that is the NextDent 300, the explanation of the product and the workflow. I will now hand it over to Mark Murray, our Global Sales Director for Dental, who can give you a little bit more information about what to do. Shall we keep the questions for after that? Is that okay? Thank you.
I'll move this forward.
This is forward. This is
okay. So thank you, Stein. So yeah, I mean, it's very, very interesting. And I think that in terms of dental laboratory, the lifestyle that you all go through, the pressures that you're under. You know, we see lots of developments. We've seen lots of developments over the years for fixed, where we see here kind of a revolution really for the removables business. And yeah, it's very exciting to be part of this, I have to say. So from my perspective, I only have a couple of slides I'd like to share with you. And it's really about the focus we have on the market, the opportunities, how we support our partners and you as the customers from the lab. So at the moment we're working with our distribution network. We're actively engaged with pre-orders because we will start to deliver these machines in the summer, actually in August. But those of you that are interested and want to move forward with this process, you recognize the business opportunities. $25 per denture. Yeah. The times factor, the fact that you don't have to have a broad range of technicians working on this. So for those that sign up with the pre-orders, we have the opportunity to visit one of our manufacturing sites, this one in Wilsonville in Oregon, and there will be course programs. You'll get a special invitation for everyone that has signed up for April, May or June. You can select which date you would like to attend, and that will give you the opportunity really to sit down and look at, deep dive if you like, into the process. So yeah, that's open to all of those that are signing up during this lab day few days. The other aspect is obviously we have some really very focused partners, because as we know, the machine is going to require support as you go forward, the material supply, you want continuity, all of this. So one of the other aspects we've done is within the next couple of weeks, the manufacturing, as Stein said, is in Netherlands, but we will be putting into a warehouse facility in the US to make sure that materials are always consistently available. And that's not just the jetted materials, but everything we've got within the NextDent range. And then obviously as well, our team, you saw the videos, there's a lot of effort going into the marketing support. And one of the things we also understand is that the laboratories need to be able to differentiate, right? So there will be downstream marketing materials that you can send out to your clinicians. So yeah, these are our partners. That's all I've got really as a slide. So I'll get Stone, if you have any technical questions, I'll hand it back over. But thank you all very much for your time.